Okay, I made a promise to you guys, or well, I guess it's not so much a promise, but I decided that I would make a video for the solutions for these problems right here for your homework stuff. Now, keep in mind, I only have an hour before classes come in, and I have to run copies of things and stuff too. So there are 60 problems. I'm going to try and do 60 problems in 60 minutes. Some problems I might skip because I'm going to say they're not a part of the final. These might not be as well. But when this next bell goes off, because there's a 7:30 bell for zero-period classes, I'm going to go ahead and start. Some work I will be able to explain better. Some I won't be able to explain as much either, though. So let's go and start. Bell's about to ring, but let's do this as I go along. Okay, let's go and get started here. I'm going to do some factoring here, show work solving each problem. I want to simplify this, basically. It didn't ask you to simplify, but that's what we're trying to do. Factoring out of 3 right here, you get 3x minus 1. Here, I'm trying to find two numbers that add to 12 or add to negative 8 and multiply to 12. So that's negative 6 and negative 2. X minus 6 is on top right here. X minus 6. Okay, 6 divided by 3 is 2, so all that's going to be left on top is 2. So all that's left is 2 over x minus 2 times x minus 1. Okay, this is the way I'm going to be able to get through these. Next, factor. Again, looking for values to factor. This will come out to, now this is stuff that you're just going to have to practice. I mean, I'm going to write it out for you, but once I say it over and over and over again, at some point you're going to have to make sure that you know it. X plus 3 times x minus 2. Okay, division is multiplying by a reciprocal. So when I divide here, the same as multiplying across 10 times x plus 1, taking the reciprocal, flipping these values. Over, this is x plus 5 times x plus 1. Okay, x plus 1's cancel, x plus 5's cancel, 10, or x minus 2's cancel. 10 over 4 is the same as 5 over 2. So this is 5 over 2. So what I'm left with is 5 on top over 2 times x plus 3. It's as simple as I can get that one. Number 2, adding. We need to find common denominators here. So to find a common denominator, it looks like this guy, 4x plus 2, is the same thing as 2, or 4x minus 2, is the same as 2 times 2x minus 1. So what I need to do in common denominator here is multiply this by 2 over 2. I can't change the number. 2 over 2 is 1, so I'm really multiplying by 1. But in doing so, I can get a common 2 times 2x minus 1 on the bottom. And on top right here, I'll have 2 times 3x plus 15 plus x plus 5. That equals 6x plus 30 plus x plus 5 over 2 times 2x minus 1, which is 7x plus 35 over 2 times 2x minus 1, which is factoring out of 7, I'll get x plus 5 over 2 times 2x minus 1. It doesn't break down anymore. That's all I could get out of that one, but that is the correct answer. I'll go and take this and drag it over because I need I can drag it very far over because I need to save some room for my next problem. Okay, finally. I can go and start factoring now, too. So whenever you do these problems, look for problems things to factor and cancel first, and then do anything else you need to. So 2 times x minus 1 on top over, that's x plus 5 times x minus 1. Division is multiplying by reciprocal. So times, on top, I'm going to take this and factor it. That's x plus 4 times x minus 3. And the other reason why I'm not focusing too much on this is because we haven't practiced this. So, I don't even know if this is going to appear on the final. X plus 5 times x minus 3. It's still good work to know. Maybe we run into this kind of stuff as we go along. Okay, that's all I can cancel. So it's 2 times x plus 4 over x plus 5 times x plus 5. That's x plus 5 quantities squared. Okay, now getting into the geometry. Number 3. The height of a solid cone at right is 18 inches. So going from here down to the middle is 18. And notice how I'm going pretty quickly here. I have no time to stop and talk. Radius is 8. Radius down here is 8. Calculate the volume and surface area. So volume will be 1/3 the volume of a cylinder with the same thing. So that's area of base, which is pi r squared, times height. So 1/3 pi r squared times height. So the volume will be 1/3 of pi times 8 squared, which is 64. Again, sorry, I'm skipping some steps here, times 18. That equals, I'll do 64 times 18. Does it say? I'm going to leave it in terms, well, I'm going to write both. Divided by 3. So this is 384 pi. Or, oh, by the way, that's cubic inches. Or times pi. 1206.4 about cubic inches. Okay, surface area. That's pi RL times pi r squared. Or not times, plus. Plus pi r squared. If you don't know that, put it on your cheat sheet, please. That's something where, if they say write surface area formula, there it is. You just have to write it. You know what you have to get out of this now. We don't have L yet. L is the slant height. That's one of the things where you can write down the formula, but you still have to know what it is. This is L. So this is 8 squared plus 18 squared equals L squared. Right there. Pythagorean Theorem. We're looking at a right triangle there. So 64 plus, I don't know what 18 squared is actually, equals L squared. So that's 388. So the square root of 388, I'm just going to go ahead and take the square root of this. It's 19.69 about, but I'm going to use the exact number I have in my calculator right now to do this problem. So surface area is pi times 8 times 19, I'll put 19.7, plus pi times 8 squared. So this number, L times 8, is about 157.6 pi. I know I'm running out of room, I'm sorry. Plus 64 pi. So that's about 221.6 pi. Sorry, one second. Let me write it up here. 221.6 pi, which that's square inches, which is times pi 696.1 square inches. And again, I'm running out of time. You know, I've done I have 6 minutes, 3 problems. Hopefully these will be quick. Which of the following cannot be used to prove two triangles are congruent? Angle, angle, angle. The other ones can be. Cool. Did a problem like that. Good. A lot of multiple choice. This will help me. In a right triangle, someone writes the ratio, number 5. Someone writes the ratio of length to the adjacent leg. So we're looking at to the length of the hypotenuse. So if you're looking at an angle here, you have ABC right here. I'm looking at this angle X. I'm looking at the leg adjacent to it, boom, or the leg adjacent to it, and the hypotenuse right there. They are trying to find the cosine of X. The cosine of one of the acute angles right there. Number 6, what is the measure of each interior angle of a regular octagon? Show all work. Okay, well here's something you're going to have to remember or utilize in some way. This formula right here says the sum of the measure of the interior angles is the 180 times the number of triangles. Number of sides minus 2 is number of triangles. An octagon is 8 sides. So n equals 8. So d is 180 times 8 minus 2, which is 180 times 6, which is, what is that, 1080? 180 times 6, 1080. So 1080 is the sum of the measure of all the interior angles of this regular octagon. In a regular octagon, all angles are congruent, and there are 8 of them. If they all add up to 1080, if I divide by 8, I'm going to get the measure of just one of them, which is 135 degrees. So the answer is A. Whoops. The answer is A. Okay, number 7. The hypotenuse of a 30, 60, 90 triangle measures 14 centimeters. So this is 14. Find the length of the leg opposite the 60-degree angle. So this is 60. Okay, I want you to keep in mind, if I have a right triangle here that's 30, 60, 90, the short side is x. That's this guy right here. The hypotenuse is 2x. So right here, the short side is half the measure of the hypotenuse. So this length is 7 right here. Now that you have that, now I could have done this multiple ways. You know, I could have used trig or anything else, but because it's doing exact numbers, you're going to have to know this. You can't just use the decimal number. This is 7. This is x root 3. If you don't know, use Pythagorean Theorem. You'll find it out. I just have no time to. This is 7 root 3. This is the leg opposite 60 degrees right here. So that's 7 root 3 centimeters. Okay, number 8. Find the total surface area of a cube whose edges have a length of 3 centimeters. Show work. Okay, yeah, see, there's not much room to do these, but let's say I have a cube. Now, a cube means like a square, like a 3D square. So all faces are squares. If all faces are squares, they all measure 3. So I want to find the surface area of this cube where everything's 3. So basically, remember that surface area really is just adding up the areas of all of your faces. Now, there are 6 faces, all of them which are squares. So if I find the area of 1, 3 times 3 equals 9 square centimeters. I just multiply that by 6. 9 times 6, there are 6 faces. 1, 2, 3, bottom, back, and left. These are all 9. So that's 54 square centimeters. We could have drawn nets and such. I'll do that in another problem if necessary. If the sum of the measures of the interior angles of the polygon is 1980, how many sides does the polygon have? Show work. This is, again, using this formula. D equals 180 times n minus 2. N is number of sides. N minus 2 is number of triangles. Again, that's what that means. 180 times the number of triangles equals D. D is 1980. So 1980, the sum of my interior angles, is 180 times n minus 2. 1980 divided by 180 is 11. So there are 11 triangles in this polygon, which make your interior angles. Add 2, you'll get the number of sides as 13. So there are 13 sides in this polygon. 10, are all sides of a rhombus congruent? Yes. Again, I'm moving quickly if I have to. 11, the length of the height of an equilateral triangle is 8 root 3. Remember, this is equilateral. All these guys will be congruent. That, and that are all congruent. Find the area of the equilateral triangle. You must first find the side using 30, 60, 90 ratios. Use the proper area formula to show work. You're lucky that they gave you this to help you out. They shouldn't have to give you that. They should tell you, once they say equilateral triangle, you should know not only are sides congruent, but angles are congruent. And if angles are congruent, triangles add up to 180, then this is 60. If that's 60 and this is 60, this is half of 60, because that's the right thing right there. So this is 30. So this is 30, 60, 90. This is 8 root 3. In a 30, 60, 90, we just talked about it. If this is x root 3, this is x. So this side is 8 right here. Hypotenuse, we can know 16, but we don't have to know that for this problem right here. All we need to know is, well, we do, because this is 16 as well. This is 16. Area of a triangle is half base times height. Not base times base. Base times height. So that's 1/2, 16, remember the whole triangle, times 8 root 3. Half of 16 is 8. 8 times 8 is 64. So we're looking at an area of 64 root 3 square units. So our area of the whole equilateral triangle is 64 root 3. So far we haven't run into not enough info or none of these problems. A regular polygon has 22 sides. What is the sum of the measures of the exterior angles? Your answer is 360. No matter what, your exterior angles always add up to 360. Doesn't matter how many sides there are. If it's 360, there's no 360 here. Here's a none of these answer. Should be 360 degrees. Okay, simplify each radical, show all work. What I want you to make sure that you know are 2 properties right here. Square root of a times b equals the square root of a times the square root of b. In other words, what you can do here is if you can find a factor of your values and get perfect squares out of it, you can simplify this and have some things that are not in square roots. So square root of 117 is actually, you can divide this number by 3. I'm thinking of that in my head. I think it's 39. So that's the square root of 3. So it equals the square root of 3 times 39. That equals the square root of 3 times the square root of 39. Square root of 3 can't be broken down anymore. Let's keep that. Square root of 39 is square root of 3 times square root of 13. So now we're looking at the square root of 3 times the square root of 3 times the square root of 13. Square root of 3 times the square root of 3 is 3. So this is 3 times the square root of 13. 3 root 13. There's my simplification. Square root of 280. Okay, I can do 7 and 40. I know that. I'm trying to get as cool of numbers as I possibly can. Root 7 times root 40. I don't know if this will help me, though. Root 40 is root 4 times root 10 times root 7. Root 4 is 2, so 2 root 70. Can root 70 simplify? I'm thinking in my head, no. I don't think I can get that any shorter. Which is unfortunate. I should have done 40 or 4 and 70 actually. I don't think I can simplify that anymore. I think that's it. Okay, a property you have to know over here is let's see, a root c plus b root c equals a plus b times root c. So the fact of the matter is I have two different roots there. I can't just add them. This isn't square root of 26. If I could find the same root under both of these, then I could add the values together and keep the root the same. That's the whole point of this. If I can get the same root underneath the hood, I can do that. So let's break these down. Square root of 8 is square root of 4 times square root of 2. That's 2 root 2. Square root of 18 is square root of 9 times square root of 2. That's 3 root 2. So 2 root 2 plus 3 root 2 equals 2 plus 3 times the square root of 2. So that's 5 root 2. Finally, root 3 over root 10. The only thing about simplification here is they don't want you to have a radical in the denominator. They say, no, you're not supposed to have that. They say that's illegal. So the way to get rid of that is multiply by the same thing to get a perfect, to get 10 out. The only thing is I have to multiply by the same thing on top and bottom because I can't change this number. So square root of 10 times square root of 10 is 10. Square root of 3 times square root of 10 is square root of 30. Can that break down? Root 10, root 3, root... No. So that's it. Root 30 over 10. Simple enough. That was for 16. Okay, which of the followings can be lengths of sides of a right triangle? So there are two things you have to consider here. Yeah. First of all, you can use you have to check all these two Pythagorean theorem, but some of them you can avoid doing. Like this one, 2, 2, 5. Triangle inequality theorem says that the sum of two values has to be greater than the third value. Like in all cases, 2 plus 2 is not greater than 5. That would look at a length of 5 here, and 2 and 2. That would cut short. It can't make a triangle. So we know it's not that one. The other ones we do have to use Pythagorean theorem because all of these can make triangles. That doesn't mean they will make right triangles though. So we have to use Pythagorean theorem with the two shorter sides to see if they match up. 2 squared is 4, 3 squared is 9. Does that equal 16? No, 13 does not equal 16. This does not work. B, 5 squared plus 10 squared equals 13 squared. 25 plus 100 equals 169. I doubt that. 125 does not equal 169. So the answer is none of these. None of these make a right triangle. A and B can make triangles. C cannot make a triangle, but none of these can make right triangles. Yeah, I'm on pace for a problem a minute problem. How many sides does a regular polygon have if the measure of each interior angle is 150 degrees? So, here's the way I like to do this problem. If you can find the measure of the exterior angles here, so here, if I have a polygon, such as a pentagon right here, an exterior angle is supplementary to its interior angle. So if this was 150, which is not in a pentagon, but if this is 150, then this is 30. And 30 plus however many 30s there are equals 360. That'll tell you how many angles there are in this thing. So what I'm going to do is first I'll say 180 minus 150 equals 30. That's the measure of each exterior angle. 360 degrees over 30 degrees will tell you how many sides there are. That is 12. Because your exterior angles add up to 360. If there are 12, so there are 12 30-degree exterior angles in this regular polygon. So that's how that worked. 19, find the length of the hypotenuse of a right triangle if the leg opposite 60 is 6 root 3. So this is 6 root 3 again in a 30, 60, 90. It's x root 3, and 2x. If this is 6 root 3, opposite 30 is 6. 6 times 2 is 12. So the hypotenuse is 12. I can't spend too much time talking about that anymore. There are a lot of review videos where I've talked about it. I already talked about it before. I need to save time. An inscribed angle measures 38 degrees. Find the measure of the angle's intercepted arc, x. The intercepted arc is twice the measure of its inscribed angle, 38 times 2. is 76. I'll write that, though, because I need to show work. Because, you know, this might say 77, and you're like, oh, it's close, but it needs to be exact. The total surface area of the pyramid if all faces are equilateral triangles. Okay, this one's tough to see, but if you can kind of see this right here, this is a pyramid. Here's a triangle, and in the back there's a triangle. Now all the triangles are equilateral, so that means not only is this 10, but this guy up here is 10. This is not the height of anything. This is looking at it like look at it from a different perspective. Here's the front, and then here could be the back right here, where these are all 10. Now this height of the slant height, this guy, would be this guy down here, which is something that you need to find for surface area. So surface area of a pyramid, let's see, do I remember the formula? Well, it's the area of the base plus the lateral areas. The area of the base is 1/2 base times height. So if this is an equilateral triangle, this is that same thing we were talking about before. These are 10. This is 5 then. When you look at half of that, you can use Pythagorean Theorem, but this is going to be 5√3. So your slant height, L, is 5√3. The perimeter of your base is also an equilateral triangle. These are all 10, 10, and 10. So your perimeter of base, which you will need to know for this, is 30. Okay? So, like I said, this stuff I'm going through quickly, but your surface area, okay, area of base is 1/2 base, 10, times height, 5√3. That's slant height, really, but it's the height of our triangle that we're talking about down here. It's all the same. So 1/2 of 10 is 5. 5 times 5√3 is 25√3. So area of my base is 25√3. Okay, the lateral area, if you remember this, or if you can access your notes and find it, it's perimeter of base times slant height. Like that. Perimeter of my base is 30. Slant height is 5√3. So lateral area is 150 times the square root of 3. So we're going to get 25√3 plus 150√3, which is 175√3 square units. I'm not seeing that answer here. I could have got this problem wrong. I don't think well, no, shoot, I must have got this problem wrong. Because this doesn't have a none of these. Hang on a sec. Okay, I know what I did wrong. It's not perimeter base, it's half perimeter base times slant height. See, that's what you do when you trying to memorize something. So let's take half of 150√3. That's 75√3. So let's do that little part again right here. 25√3 plus 75√3 is 100√3. I could write the decimal approximation, but here they have 100√3. So sorry for that screw up. That was my bad. That is where you need to make sure you access the stuff and know it. You're only following me to make sure I'm doing things right as well. Okay, quadrilateral ABCD is similar to quadrilateral HGFE. That means there's a similarity ratio, and you can see it right here by comparing 4 and 12, because these are corresponding parts of similar triangles. They are proportional. So this length is 3 times bigger than this length. So our ratio is 3 to 1. So y equals 3 times 8, which is 24. So y is 24. By the way, we're trying to find the perimeter of this quadrilateral, so we need to find y and x. X is 3 times 3, which is 9. So the quadrilateral is 21 plus 12. That's 33. Plus 24 is 57. Plus 9 is 66. So perimeter 66, that's C. Okay, NQ is parallel to OP. Calculate the length of MQ. If MN is 9, NO is 7, and MP is 20. Okay, this is interesting. You have similar triangles here because you have parallel things here, so you have corresponding angles congruent here and here by angle, angle. Triangle MNQ is similar to triangle MOP. So if that's true, then we have a proportion right here. MN is to MO, right? MN is to MO, so 9 over 16 is your similarity ratio. as this unknown MQ, x is to 20. So 9 over 16 equals x over 20. Cross multiply. You get 180 equals 16x. And divide by 16. You get x equals 11.25. Weird number, but it is an answer here. MO, really, or MQ, really, is 11.25. Okay, in circle O, measure of angle AOB is 25 degrees. Oh, OAB, I'm sorry. This is 25. Automatically, I know two things. One, these are radii. They show you that too, but it's an isosceles triangle, so this must be 25. They say calculate the measure of arc AB. So I'll do this two different ways. I'll do the isosceles triangle way first, and then I'll do it the other way. I don't have much time, but shoot. I think when we run true-false problems, I'll be able to go through those quickly. If these are 25, then this, these add up to 180. So this x, this thing we don't know, that's 25 plus 25 plus x equals 180. 50 plus x equals 180. X equals 130. If the angle is 130, its central arc is also central angle is 130. Its intercepted arc is also 130. So this is 130 degrees. The other way I could have solved this problem was that A is 25 degrees. Here is A is an inscribed angle. Here's A's intercepted arc right here, BC. BC is twice the measure of A, so it's 50, 25 times 2. Now this is a semicircle, which is 180 degrees, so this is 180 minus 50, which is 130. So it's the same thing both ways. You get 130 either way. Let's go and zoom back out, and let's look at which answer that is. 130 degrees. Those two different ways to do that. Okay, 25. The diameter of a circle is 8 centimeters. That is not a circle. The area of the circle is, so I don't have to draw this, but I will. Here's your diameter crossing through the center. If this is 8, area is calculated by its radius. So radius is 4. Area of a circle is pi r squared. So area is pi times 4 squared, which is 16 pi square centimeters. So that'll be B right here. Okay, not even halfway through. Again, hopefully that true-false helps. MN is cut by transversal T, and these guys are parallel. Which statement is true about X and Y? X and Y are corresponding angles. Corresponding angles are congruent. Angle X is not similar to. This is similar. It says angle X is similar. Well, actually, I don't know what that means. If that means congruent, that's true. Otherwise, I don't think that's what that means. I would say X is equal to Y. Okay, these are not supplementary, so don't equal to 180. They're not less than, so it's none of these. They are congruent. Okay, AB is parallel to CD with transversal Q. That line, and MX is measure of X is 128. That's odd. That's not drawn to scale at all. Oh well. Measure of angle T is going to be the same. These are vertical angles which are congruent. So T is going to be 128. V and T are same side interior angles, so they're supplementary. So V is going to be 180 minus 128, which is 52. So we're going to find one where T is 128 and V is 52. That's C. Well, the C must be a D, because that's already a C, so they're trying to trick you there. This is D, 152. Okay, 28. The lengths of two sides of a triangle are 13 and 24. The third side cannot exceed, hint, find the maximum. So triangle inequality theorem says if I have two sides right here, 13 and 24, 13 plus 24 equals 37. Now the thing is, I cannot have a triangle that is greater than 37. So, I'm sorry, that is 37 or greater. Because if you have 13 plus 24, you're looking at a straight line, right? If this is 13 plus 24 right here, then I can't get anything greater than 13 plus 24 right here. So this is kind of a weird trick question. In this case, the side cannot, technically, it cannot be 37. So I don't know if they want the answer to be A, because technically that is wrong. Okay, that would be wrong. The only answer in this case is that it couldn't exceed 11. So the reason why I'm saying 37 is because 13 plus 24 equals 37. 13 plus 24 has to be greater than your third side x. If it's 37, it's not greater than 37. That's why I'm putting 11. 29. Find the total lateral surface area of a cylinder with radius of 3 and height of 7, not including the bases. So what we're looking at there in a cylinder is it looks like that. Well, that's a bad one. The radius is 3. The height is 7. Okay? When I unravel the toilet paper of a cylinder, we're trying to find this lateral area right here. This length is the same as the length of your circumference of your base. So my circumference is 2 pi r, which is 2 times pi times 3, which is 6 pi. So the length right here is 6 pi. Now remember, this is a rectangle, and the height is 7. So the lateral area is 6 pi times 7, which is 42 pi. So your answer right there. It said not including the bases. We didn't. We had to use the base, though, to help us find that length across right there. Number 30, solve for x in the regular hexagon if each side is 4 meters. Well, there are a couple ways that I could really do this, but wait, what is x? I'm assuming x is this right here. It's not an angle. They wouldn't say that if they have this length. X must be this guy right here. Okay, if this is 4, then this is 4. If that's 4, this is 2. Okay, in 2, I'm not going to use trig. This is a 30. Yeah, this must be because we're looking at these multiple choice options. An a regular hexagon has central angles like this one right here. A central angle is 360 over 6, which is 60 degrees. So if this is 60, then half of that is 30. So this guy right here, I don't have much room. Right here is 30 degrees. This is 60 right here. They made this right triangle thing so big. I'm going to redraw this. I got a 30, 60, 90 triangle. Again, we're using a lot of 30, 60, 90s. We haven't used many 45, 45, 90s in this class, period. If the short side is 2, the side opposite the 60 is 2 root 3. So this one is 2 root 3 meters over there. 31, what is the equation of a circle with center at 0, radius 6? I'm going to skip that one. We're not doing that. You might learn in Algebra 2 trig or Algebra 2. I don't think they're doing conic sections, so we're skipping 31. Okay, true, false. An octagon has more sides than a heptagon. Octagon has 8 sides, heptagon has 7. That is true. Let's see how fast I can get through these. Median of a triangle bisects the angle. I don't know if that's true. A median, I do believe, is something that... Shoot, what's the median of a triangle? I think the median is something that crosses through this side over here. Is it always true that when it's opposite that it bisects? I don't know if that's true. That's a question mark. I'm sorry. I am genuinely sorry. I don't know if that's true or false. I think it's false. Because I'm thinking of an example when I have like an obtuse triangle right here, and I have the median go through right here. I'm trying to decide if that divides those into 2 congruent things. I don't know. That's still a question mark. Every square is a rhombus. What they're saying is that the properties of a square, one of the properties of a square is it has 4 congruent sides. Another property is it has 90-degree angles, but if it has 4 congruent sides, that is the same as a rhombus. That's true. Now, every rhombus is a square is not true, because not every rhombus has 90-degree angles. If triangle BOY is congruent to triangle GRL, that's boy and girl, then OB is congruent to GR. That is corresponding parts. They're asking if those parts are congruent. So OB is congruent to GR. Yes. In those 2 triangles, those two parts correspond. You can draw them out if you want to make them identical or whatever. Now, they wrote them in different ways. It should have been OBRG or BOGR, but it still is true. Maybe that's how they're trying to trick you. Angle, angle, angle is one way to prove triangles congruent. False. We already talked about that. Angle, 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 side are the only ways to prove triangles are similar. You know what? I don't know. Is that true? Why don't you guys tell me? The thing is, look, I'm going to say yes. I'm going to say that's true, but it doesn't restrict it. Look, you can do angle, side, angle, but that makes triangles congruent. But congruent triangles are similar. So it could be a trick question and say, no, you can use all the congruency ones. But that means they're congruent. We're looking for strictly similar. Strictly similar. That's why they underline it. All angles inscribed in a semicircle are right angles. True. That's something you want to know. This is a right angle. This is a right angle. This is a right angle. This is a right angle, etc. The circumference of a circle is a little less than 3 times the length of a diameter. What? No, it's a little more than 3 times like the diameter. If you think of pi, because circumference is 2 pi r, or diameter times pi, which is really the one I want to look at. Pi is about 3.14. Now, it doesn't matter what it is. The fact is, it's greater than 3. So if pi is greater than 3, then d times pi is greater than d times 3. So it says circumference of a circle is so circumference is here. Circumference is greater than 3d, not less than. So false. It is not less than 3 times the length of the diameter, it's greater than. 33, 34, and 55 are the lengths of the sides of the triangle, then the triangle's a right triangle. This is true. Now you can do Pythagorean Theorem and find it out, but I know that 3, 4, 5 is a special triangle. If 3, 4, 5 is, then so is 6, 8, 10, because that's 3, 4, 5 times 2, etc., etc. This is 3, 4, 5 times 11. 3 times 11, 4 times 11, 5 times 11. That still works as a special right triangle for a 3, 4, 5 relationship. In a 30, 60, 90 triangle, the side opposite the angle with a measure of 60 is half the length of the hypotenuse. That is false. Again, if you look at those right triangles again, like here, 30, 60, 90, that's going to be equivalent to this one, x, 2x. That's opposite 30. Opposite 60 is x root 3. So that is false. That would be x root 3 compared to 2x. 43, if the corresponding side of 2 quadrilaterals are proportional, then the 2 quadrilaterals are similar. If the corresponding side, I guess sides. Yeah, I guess so. Well, actually, you know what? I don't know if that's always true. I know it is for triangles. If you have like 2 to 1, 2 to 1, the only question is, can I change the angles? Like, can you manipulate the angles meanwhile having this proportion? Because you could possibly have, let's see, that longer, shorter. I'm going to say that's true. You know, there are some of these that I just don't know. And if it's on a test, I don't expect 43 or 33 to be on a test. Because we have not talked about it. We haven't done constructions. That's what that one has to do with. A ray has exactly one endpoint. That's true. A ray, by definition, has one endpoint, and then it goes off forever. A line goes off forever both directions. This is ray. This is line. A segment has 2 endpoints. If a statement is true, then its converse is always true. False. I wonder, then, the converse. If its converse is always true, is the statement true? No, that's also. Whoop, I just wrote true. That's false. 46, the diagonals of a trapezoid are congruent. False. I'll give an example. Remember, whenever it's false, that means you can give a counterexample. So, for example, if I have a trapezoid is parallel segments right here. I'll draw a big one out there. These are the parallel parts. These are these parts right here. Is this congruent to that? I don't think so. I don't think those diagonals are congruent. Now, it's not drawn to scale per se, but that's an example of, like, if this length is 2, this is 10. No, these aren't going to be equal. Two segments which do not intersect are parallel. False. Here's an important thing. This is an always thing. Are they always parallel? Okay. I can draw 2 segments. Here and here. Okay. The big thing about segments, let me make them black. The thing about segments is that they can end. We just talked about that. They have endpoints. In lines, when they go on forever, if they're not parallel, eventually somewhere, like these keep going down the line, eventually they'll intersect wherever. But if they're segments, even these two, these are segments, they are not parallel, but they do end. They do not intersect. There are examples of that. If this said 2 lines which do not intersect are parallel, that would be true. Segments and rays are false. Generalizing from specific information is called inductive reasoning. I believe that's deductive reasoning. We haven't done too much in deductive reasoning. I did 1 lecture on it. I think this is false. I think it's deductive reasoning. You know what? I can't remember. Well, generalizing from it. Generalizing from it, I think, is inductive reasoning, yes. I gave examples. I think it was in like n number 4 or something like that. You can look back at that. A scalene triangle can be equiangular. That is false. It cannot have equal angles if, by definition, a scalene triangle has no equal angles. Okay, solve and show all work for the following problems. I think I made up time there, which is nice. The sum of the measures of interior angles is 14 God. So these aren't multiple choice, so let's solve and show. 180 times 14 minus 2. No, understand how this formula. So 14 God is 14 sides. 14 sides is 12 triangles. That's really the way I'm looking at this. 12 triangles times 180 degrees equals 2160. So some of these don't take my word for it because I can't, because there's no multiple choice. I can't guarantee I do these right all the time. Find the circumference and area of a circle whose radius is 24 centimeters. So I have a circle. The radius is 24. Okay, circumference is 2 pi times radius. I'm not going to write r this time. I'll go right through that. That's 48 pi centimeters. Again, if there's some fill-in-the-blank stuff, I think they want you to leave this in terms of pi. They want you to leave units wherever. Area is pi r squared. Pi times 24 squared. 24 squared, was it 576? I think we did that once. 576. So that's 576 pi square centimeters. 52, what is the area of a right isosceles triangle whose hypotenuse is 16? So here's an example of 45, 45, 90 triangle. In an isosceles triangle, the equal angles are equal, but in an isosceles right triangle, the non-90 degree angle are both 45. 45 plus 45 plus 90 is 180. So these are 45. So this is a 45, 45, 90 triangle. In a 45, 45, 90 triangle, if these sides are x, this is x root 2. So to get these two, because to find the area, I need area of base times height. I could have done it this way or the other way. It's still 45, 45, 90. To find this, to go from x root 2 to x, I need to divide by the square root of 2. So I need to take 16 and divide by the square root of 2 to get x. Okay, so x is 16 over root 2. Right now I'm going to leave it as that because I think when I multiply it's going to cancel out the root instead of simplifying it. So both of these are 16 root 2. So my area is 1/2 base times height. 1/2, well, let's see, 16 times 16 is 256 over, let's see, 1/2. Root 2 times root 2 is 2. So that's 256 over 4, 1/2 times 256 over 2. 256 over 4 equals 64. 64. So 64 square centimeters is the area of my isosceles right triangle. Again, special right triangle there. You could have done trigonometry. I don't know if you would have had an exact answer of 64 then. A sector has a central angle of 80 degrees and the radius is 6 centimeters. Find the area of the sector. Okay, good. We haven't done one of these problems in a while. Okay, my center was about here. If I do 80 degrees, it's a little less than 90. Let's put it right there. Okay. This is 80 degrees. I want to find the area of this. I want to find the area of that whole shaded region right there. So remember, this is 80. My radius is 6. Okay. To find this area, this is just a fraction of the area of the entire circle. In fact, it's 80 over 360 amounts. So the area of the entire circle is pi times 6 squared, which is 36 pi. So I want to find the proportion that's the same as 80 over 360. 80 over 360 equals x, my unknown sector, over 36 pi, the area of the entire circle. Remember when we talked about these proportions? I did in just another thing I was talking about, the previous section. I want to reduce this a little bit. 8 over 36, 2 over 18, 1 over 9. This is 1 over 9? Yeah. No, this isn't 1 over 9. 8 over 36. 4 over 18. 4 over 18 is 2 over 9. So 2 over 9 equals x over 36 pi. Cross multiply. 9x equals 72 pi. And x equals 8 pi square centimeters. So the area of that sector here is 8 pi square centimeters. That's 8 pi out of a total of 36 pi. That's the same as 80 over 360. It's basically, it's 2/9 of the area of the circle. 2/9 of 36 pi equals 8 pi. Okay, last page. This one's interesting. This is a question. This is kind of a question that I asked you to try and do in your very first test. It was in written form. It was a very hard question. In the right rectangular prism shown out right below, AD is 15 meters. So let's start writing these. Hope this doesn't kill my time. Hopefully these problems aren't too long. AD is 15. Now this is a rectangle, so that BC is also 15, if that helps. CD is 20. CG is 20. So remember, this is 20, this is 20, all that. What is the length of the diagonal BH? Now this is 3D, so BH is going from corner to corner. Think of corner of room, like the floor or the wall in one room, all the way to the other corner, like looking through space, not against a wall. So what's going to happen here is I'm going to use Pythagorean Theorem twice. So if this is 20, this is also 20 right here. This is 15, this is 20, etc. I want to use Pythagorean Theorem on this right triangle down here. Find this hypotenuse. When I find this hypotenuse, this will then be the leg. I'll call this x. This will then be the leg of this new right triangle right here, right there, that'll get me that guy up there. So I'll draw that one in green a little bit. So this is green. In the end, I want to find this length BH right here. I'm going to call this C. And there's actually good news to this one, at least in the beginning. I'm going to have a special right triangle, so I don't want to use Pythagorean Theorem, really. I'll set it up for you, though. A squared plus B squared equals C squared. 15 squared plus 20 squared equals X squared. I'm looking at this right triangle down here, right there. Now, this is a 3, 4, 5 special triangle. Remember, 3 times 5, 4 times 5. This will be 5 times 5. So X equals 25. So this guy down here is 25. Now I'm looking at a right triangle where I need to solve for C. So I have 20 squared plus 25 squared equals C squared. I don't think this is a special right triangle. This is not 3, 4, 5 for sure. So that's 400 plus, I think, 625 equals C squared. 1025 equals C squared. So C equals the square root of 1025. What I'm going to do is, so square root of 1025. I'm not going to give you an approximate number, or I will eventually, but I want to reduce this. I can divide by 25 there. I hope you can see why I know I can do that. Times square root of 41, I divided by 25, so that's 5 root 41. That's an exact number. That's in meters. 5 times the square root of 41 is about 32. It's about 32 meters. It's 32.02, but it's about 32 meters. Okay. Okay, DE is parallel to AB. Calculate the length of BE. Okay, we just did a problem like this. Now remember, what this really is similar triangles. If you can see that this triangle is similar to this one, it's growing by the same amount, you have angle, all that stuff, then you could set up a proportion. CB is to CE as CA is to CD. So, this BE is our unknown. Now the thing is, BE, well this is CE right here. BE is X, CE is 9 plus X. So that's the important thing you need to understand. If we're solving for this unknown X, we need to make sure that we say 9 plus X when we say CE. So 9 is to 9 plus X as, I think that's a 5. I need to be sure. As 5 is to, this is 5 plus 19 right here. This is 24. Not the whole thing is 19. This right here is 24. Just like there, 9 plus x, 5 plus 19. Cross multiply 9 times 24, 216. So 216 equals 5 times 9 plus x. I'm going to move down here for a second. 216 equals 45 plus 5x. 5x equals, I don't know why I'm using the calculator for this, 171. So x divided by 5 is 34.2. So that's 34.2 units there. Okay, number 56. If a 13-inch flagpole, hang on, the bell's going to ring soon. Let me pause this. You know what? I'll stop the video here, and I'll do a second part if necessary. There are only 4 more problems. In fact, we're not even going to do these problems right here. These problems are not problems that we are going to do. So there are really only 2 more problems. This is Sohcahtoa. Please know how to do that one. I don't think we're going to have a problem like this. So in fact, you know what? Let's kill the video right now. This is Sohcahtoa. I'll set you up. Sine x equals 18 over 25. So you're going to take inverse sine. Shoot, I'll just do this problem. 18 over 25 equals x. 18 over 25. Inverse sine is second sine up there. That's 46.06 degrees. There's that one. We're not going to have 57, 59, or 60. Okay? That was everything. I made it in 50 minutes. Awesome.